In the last video, we saw looking at the limit from the left and the right. Those are the one-sided limits. We're going to talk about them now, as well as limits involving infinity. So this is a two-sided limit because when we are looking at the limit, what we are doing is we are asking the question, as x approaches a certain value a, what is the y value of our function as we come in on each side of a? So as I come in from the left of a, I'm looking to see what the y values are doing in that region. And then as I come in from the right of a, I'm looking to see what the y values are doing there. Each of those are what are known as one-sided limits. If I look only on the left or only on the right, that is a one-sided limit. We notate a one-sided limit looking from the right by putting a plus sign as the superscript on the a there. So this is the limit of f of x as x approaches a from the right is equal to L. That means that the y values get closer to L as x approaches a from values greater than a. The left-hand limit we notate with a superscript of a minus sign on the a. And it means the same thing, but we're looking at approaching from values less than a. So here, if I look at the limit as we approach to from the right is on numbers bigger than a. Bigger than a would be right here. So I'm using 1/2 x squared to evaluate that limit. So I can plug directly into the 1/2 x squared, or I could look at the graph here and I see that we're getting closer and closer to the value 2, but that's also equivalent to evaluating the limit by plugging into the function there. So I would plug in 2 squared, get 4, half of 4 is 2. Now, from the left are values less than 2. This is the curve that's doing values less than 2, and we can see that denoted here, less than 2. So I'm plugging into x plus 6. So this one is equal to the limit as x approaches 2 from the left of this formula, x plus 6. So again, I can plug in here, 2 plus 6 is 8. Or I can visually see on the graph as we get near, these y values are coming up to 8. So when x is bigger than 2, that's my right-hand limit, we use that function. When x is less than 2, we use this function. That's the left-hand limit. Since the two are not equal, the two-sided limit does not exist there. And we see that because from the left is going to a different value than from the right. So we would say the limit as x approaches 2 of f of x does not exist. Let's look at the limit from the right and the left of 0 for the function square root of x. So square root of x, I would just plug in the 0 and I get square root of 0. That's 0 when I'm on the right. Because if I look at the graph, our graph goes like this, and on the right of 0 is over here. So we're coming in towards 0 that way. But on the left, there is no function over here. So the limit on the left does not exist. So I would say the two-sided limit does not exist. The left-sided limit does not exist. Only the right-sided limit exists and is equal to 0. So the two-sided limit exists only if the left and the right-hand limits both exist and equal that same value. So notice here, my function is getting larger and larger. Before we said this limit does not exist, we can say a little bit more. It does not exist because it keeps getting bigger and bigger. The way we notate that is by saying it equals infinity. Now there is no such number as infinity, so this is a statement that doesn't work. Nothing can equal something that isn't really existent, but this is notation to say that the function increases without bound. Similarly, we write it equals negative infinity if it decreases without bound. This is for a right-hand limit. The notation is the same for left-hand limits. So here, the right-hand limit, the left-hand limit and the two-sided limit all increase without bounds, so they're all equal to infinity. Here they're all equal to negative infinity. Here my left-hand limit is equal to positive infinity, the right-hand limit equals to negative infinity, and all I can say about the two-sided limit is that it does not exist. Here my left-hand limit is negative infinity, the right-hand limit is positive infinity, and the two-sided limit does not exist. Now, limits where we get back equals infinity or equals negative infinity are where our vertical asymptotes on the graph are, as we can see here. All of these make vertical asymptotes on the graph. So the line x equals a is a vertical asymptote for this function. All right, we know we get a 0 in the denominator when x is equal to 2, so we know that our vertical asymptote is x equals 2. We can show that by looking at the left-hand and right-hand limits. So when I look at the left-hand limit, it's going to negative infinity, and when I look at the right-hand limit, it's going to positive infinity. We can also see it from the table. The left-hand limit, notice we're getting large negative values, and the right-hand limit, notice we're getting large positive values. So we would conclude we equal infinity and negative infinity for the